This. All right, we're in business. Okay, so here's a couple of problems from chapter 7. I've already done a problem session on chapters 4 and 6, right? So see, I don't like this. This is better. See, problem session 13, I think. Okay, so today, problems from chapter 7. So in the book, this is on page 190 that I'm looking at right now. Okay. So, okay, let's start with some very easy ones. Let's take a look at number 24 or 7.24. Yeah. So we're asked to determine the output of each gate. So we're given this, so let's just do one of them. So we've got the following, like this.
The boys.
And we've got 1, 1, 0, 1, 1, 0, 0, 1, 0, 1, and 0, 1, 0, 0, 1, 1, 0, 1, 1, 1. Okay, so again, so this is an OR gate. Actually, in the question, it says that it's an OR gate, but you should remember what they look like. So this is an OR gate, right? And when you take if you have sequences as inputs, how do you compute the OR? Is just coordinate wise, right? So this is not very difficult, right? So I'll just put them one on top of another so that'll be easier for me. And I can actually cheat. Well, it's not cheating, but that. Okay. And so, okay, they're not really lined up very well, but so I'm going to take the OR again, the OR, you know how this goes, right? It's the maximum. So this is 1, 1, 0, 1, 1. Ugh. This is better. Yeah, so far so good. This is 1, 0, 1, 1, 1. So this should be your output, right? Right there. Okay. So really straightforward, nothing difficult. All you have to do is know what the things mean, right? There's no, once you know what it means, that's it. You just apply the recipe and that's it. Okay. Again, if you have questions, just jump in, and I'm going to do a few. And after that, if you have suggestions for me to do other problems, that's great. Okay. Let's try so I'm not going to do all of them, obviously, but just a sample of these. So number 25, we're given sequence A, which is 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, and sequence B is 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. It seems I don't have the same number of bits here. Wait. I think I have one too many here. Yeah. Yeah, that's better. And we're asked to compute, for instance, A plus B, right? So you remember plus is the notation for the OR, right? right? So if I'm going to compute, you know what? I just did an or. So what I'm going to do is I'm going to change it to an and. Let's just do that. Let's modify this. Let's do that. So this is and, right? So the product, it could be written as AB simply, okay? So what is that? Let's compute that, right? So let's copy this, let's put it here. Let's move this up. Okay, so the and is the minimum, right? So it's like the min, so this is 0, 0, 0, 0, 1, 1, 0, 1, 1, 0. That's it, okay? So nice and easy. Actually, this wasn't one of the questions there, but I changed it. But there's a similar one in there that you can check out. So I changed it just to make sure you don't mess up later on. Change from actual question. Okay, so I didn't use exactly question 24A. Okay, let's take a look at this 25A, sorry. Let's look at number 26. We've discussed this before. I didn't do an actual example per se, but because I was using slides, but here is a question. So I'm given 4 inputs, A, B, C, D. And I'm asked to find special sequences which give all the different possible values. So giving all possible values for the inputs, right? So for example, if you had to compute the, so let's just write an example. So let's say I had an expression x equals to a complement a bar times b plus cd, right? If I had to compute the output of this gate, right, I need to get all possible different inputs, right? Right, so the compute the table, right? So I need all the possible inputs for A, B, C, and D, and we discuss special sequences, which is one way of listing all possibilities. And how do you do that? Well, first of all, you should know, so how many possibilities are there that you should get, right? It's 2 to the power the number of different inputs, right? So here we have 4 inputs, 2 power 4. So this is important. So the number of different inputs total is 2 to the 4, which is 16. So you should get 16 different inputs to compute all possible outputs, right? So how can you do that? These special sequences is you alternate zeros and ones at a higher and higher rate, okay? So if I have 16 different inputs, half of them will start with 0, half of them will start with 1. So I can start with this, right? So I'll have 8 zeros and then 8 ones, right? And then I'm going to alternate twice as fast now. So I get 4 zeros, 4 ones, 4 zeros, 4 ones, then double the rate at which they switch, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, and once more, so 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. And there you go. You have all the columns are your inputs, right? So you have 16 different inputs. Obviously, they're all different, right? The way we built it, they have to be all different. And so that's it. Okay, so that's one way of doing this. Okay, another way is count in binary, right? So look at the left-hand column, it's 0 in binary. If you look at, so an alternative, count 0 to 15 in binary. That's the same thing, right? Right, so if you look at the columns and you look at the lowest so the lowest row as your least significant bit, then you see that you're going from 0, 1, 2, 3, 4, 5, 6, 7, 8, and that's exactly what you have, right? You're counting from 0 to 15 in binary. So two totally different ways of listing these things, but you will get the same result. Okay. All right. Hopefully that's good for you. Let's do number. Yeah, let's do number 27A. Let's do that. Okay, so we're given a logic circuit, which I'm going to draw right here. Like this. Sorry, it's a bit sketchy, but what the hell? This is A. I've got B like that. This. I've got C like that. Okay, hopefully you see what this looks like. And we're asked to write down a Boolean expression for this circuit. Right? So what do you need to know? You need to know what each gate means, right? The pictures. So obviously, if you don't know that, you're in big trouble, right? The curved one, right, is an OR. This is OR. The flat one is an and the triangle like that, that's a not, right? Right? So either you know it or you don't. If you don't, you're in trouble. If you do, it's easy. That's it, right? So now I want an expression for this. So the output Y is the OR of two ANDs. What are these ANDs? The top one is the AND of A and not B, right? So how do we write that? Like that, right? Or prime. You can use prime or over bar. It's the same, okay? No problem. So it's an OR, and then the other AND is not B, C, right? So B prime C, right? So this is the answer we're looking for. Nice and easy, okay? So the second part is to compute the truth table of this. I'll let you do that. That's easy, okay? I mean, it's easy. None of these problems are very hard, as you can see, right? There's really there's not much. Do the current web work exercises count? Yes. Yeah, okay. So look, in Omnivox, I add those in as I go because I'm creating these webworks as I'm going. So yes, if I say that there's a webworks open, it'll count unless I tell you it doesn't. Okay, so if it doesn't appear in the scheme, it's just I haven't had time to add them in at that moment. Okay, so I will add that in. Okay. Yeah. Yes. Okay, let's put the chat here. Okay, let's do a hard one. Let's do a harder one. But I don't think I have one in the book, but let's just make one up. Okay, so here's a question. So find a Boolean expression for the following truth table. So I'm giving you a truth table, which will look like this. So it has 3 inputs, 1 output, okay? 3 inputs means 2 to the power 3, which is 8 different possibilities for the truth values. Let's do it with the special sequences. So again, that's 8. So half of them are zeros, half of them are ones. Then I double the rate at which these change, 0, 0, 1, 1, 0, 0, 1, 1, and then 0, 1, 0, 1, 0, 1, 0, 1. Okay? Or again, you can start on the left, or you can start in any direction you prefer, and just count in binary from 0 to 7. That's the same. Yeah, I will. Yes, I'll do one like that. If you can find one and point one at, but yeah, it should be easy to find one. Okay, I'm fine. Okay, so here's the table. As you can see, I just totally made that up at random. Okay, and I'm asking to find a Boolean expression for this truth table. Maybe I should change that a little bit. Let me just, let's try to make it, let's put a 1 here. Okay. Okay, so if you remember, I did one like that in the slides, but now I'm gonna do it live with a pen. It's a little bit better, I think, to explain. So what I'm looking for is an OR of ands. Just like the previous example, in a sense, if you think of the picture, this is what I'm looking for. Okay, so how does this work? Think of, if I write an expression like A, so I'm going to explain a little bit more here. I'm going to review a few things here. So if I write something like A, B bar C, okay, when is an expression like this true or equal to 1? The only way to make this equal to 1 is for A to be 1, C to be 1, and B to be 0. Okay, so the only way for this to be 1 is if A is 1, B is 0, and C is 1, right? This is the only way. If you put any other 3 values in there, but rather than 1, 0, 1, any other triple, you will get the value 0, right? Because one of the 3, A, B bar, or C, will be 0, and that will absorb everything, okay? So that's the like the key point. If you understand that, then you can build the Boolean expression for anything. So how do you do it? So I'm going to look at columns in the table sorry. that output y equals to 1. Okay, so this is what you do. So you look at those columns which give you, that's not what I wanted, sorry. That's what I want. So you look at these columns. Okay, so these are the key things. So I'm looking, so you want an expression that will give you 1, let's say when A is 0, B is 0, and C is 1. So we want an expression that outputs 1 precisely if A is 0, B is 0, C is 1, right? Look at that first column. A is 0, B is 0, C is 1. How do I do that? If you look at this example that I just gave, you want A bar, B bar, C. That's going to give you 1 precisely on those 3 values, okay? So let's just copy this. Copy. Paste. There we go. Okay, so expression A bar, B bar, C is 1 exactly on A0, B0, C1, right? This is the only way that you can make this 1, okay? So that's my first column. I do the same for the second column, okay? So this is, let's call that 1. I'm gonna do 2. After that, I'll do 3. I'll do 4. Okay, so for the second one, I want an expression that gives me 1 precisely when A is 0, B is 1, C is 0. So I'm going to take expression A bar, B, C bar. Right, so I want 0, 1, 0. All right. So for the third one, I want my expression to be 1 for input 1, 0, 1. So I'll take 1, 0, 1. 1, 0, 1. And finally, the last one, 1, 1, 1. That's easy. ABC. Okay, so I've got these expressions that if you plug in the desired column, either the first, second, third, or fourth, you will get 1 and nothing else. Okay, it will never light up to 1 other than on that particular triple. So now what is Y? It'll light up as 1 if either you get the values in column 1 or the values in column 2 or the values in column 3 or the values in column 4. So you take the or of these 4 expressions and you get what you want. So it'll be A bar, B bar, C plus A bar, B, C bar plus A, B bar, C plus A, B, C. Right? So think about this. That expression here will, when is it 1? It is 1 when one of those 4 lights up to 1, right? So for which triple will one of these light up to 1? It's exactly those columns that we picked out, right? It has to be one of those 4. If it's anything else, none of these will light up to 1 and Y will be 0. And if you take one of those columns and you plug that in, one of those 4 exactly will light up as 1. And so y is 1. And so you get exactly what you want. That's it. Okay? So that's, again, the key observation is if you take the product of variables or their negation, this thing will be 1 exactly on one sequence of inputs. Okay? How did you get the column, the row y? I made it up. Is that what you mean? Those values for y? Yeah, I just made it up. I could change that to anything. This is, I didn't have one in the book, so I just made it up. Was that your question? Yes. All right, good. Okay. You might be asked to draw. Oh, let's do another one. Here's one. Okay, here's another one. This is number 32. I'll do C. That's a cool one. Okay, so I'm going to draw a picture. Okay, so we're asked to find the Boolean expression for the switching circuit. So here's the switching circuit. Let's try this. I've got that, 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 that. Okay, this is A, this is B, this is C, this is D. Okay, so you remember how this works. The lamp, so let's this is your battery. This is your lamp, right? And the lamp will light up if the circuit is closed, right? And closed means the value at that point is 1, okay? So how does this work? So you want the thing to light up when these things are closed. So if you remember how this works, okay? So if you have 2 gates, one after another, they have to be both closed for the value to go through. Erase what I said about the 1. I was thinking of something completely different. I'm sorry. I was thinking of transistors, and that's not what I want to talk about. So if your two gates are closed, if they're one after another, right? If both are closed, then you'll be closing the circuit, right? If one of them is open, the circuit will be open, okay? But if they are parallel and you want to close a circuit, it suffices to close one of them, right? It's an OR, right? So if you remember that. So in parallel, so if they're in sequence, it means that it's an AND, and if they're parallel, it's an OR, right? So if you look at this, okay, so this will be the AND of this. So the output, let's call the output Y. It's A, and what's inside here is an OR of that top row, which is BC, and an OR with the D like that, right? So this is what we're looking for. right? Okay, so let's take a look. So this is the and. So for this whole thing to be closed, you want both the A to be closed and that little piece to close. And how does that little piece there close? Either both B and C are closed, that's the and of B, C, or D is closed, right? So that's the inside part, okay? Hopefully that makes some kind of sense, okay? All right. Number. Okay, number 42. That's the only one that I find as required. This is on page 161. So page 161, number 42. This is in chapter 6. Okay. So we have the following question. So a survey of 100 students produced the following statistics. Okay, so we have 100 students. We have 32 who study math. We have 20 that study physics. We've got 45 that study biology. We've got 15 that study math and biology. We've got 7 that study math and physics. We've got 10 that study physics and biology. And we've got 30 that do not study any of these. Okay, and the question, there are several questions, but the first question is the key question. How many study all 3 topics? Okay, that's, I mean, they're all the same. If you look at the one that I did in the slides and you look at this one, they are exactly the same. Okay. Okay, so how does this work? So I have a universe of 100 students, and I have these 3 subsets. There's the students studying math, those studying physics, and those studying biology. And some will study exactly 1 or maybe 2 or 3 of them, or not at all. And I have to figure out basically how many study exactly what. So let's draw a picture of this situation. And I'll make it bigger in just a sec, but this is my universe, and I have the math, I have the physics, and I have the biology here. And what I want to know is how many study all 3. In fact, what I'd like, once you know that, you'll be able to figure out who studies exactly what, where, okay? So let's try to use the information we're given. So the first thing to notice is that you have 30 that don't, out of the 100, that do not study any of these. So the first thing you see is that you know this number here, it is 30. We have a total of 100. Okay, so that means immediately you know how many study at least one of these three topics. It's 70, right? Okay, so I'm going to copy this here. I'm going to move here. Okay, so what we know is we've got 100 minus 30, which is 70. That's study at least one of math, physics, or bio. Okay, so if I'm looking at this as cardinality of sets, we have a formula that tells us the following. So this is really important, is that, so let's call these three sets M, P, and B. We know that the number of elements in of these three sets, how can you compute that? You can compute it this way. You count how many students study math. Then you count how many students study physics. Then you count how many study biology and you add those up. Are you done? No, because you're making an error because you've counted people more than once, very probably. Okay? Unless everybody studies exactly one of these, then you're going to, there's a mistake. So how do you get rid of the mistake? You say, okay, those that study both math and physics, I've counted them twice. I've counted them once in math and once in physics. I'm going to subtract that. I subtract those that study both math and physics. I have to do the same for math and biology. And I have to do the same for those that study physics and biology. Now it should be fine, right? No, because now if you think about it, think of those students that study all three, right? You've counted them once for math, once for physics, once for bio. So you've counted them three times. But now you've removed them when you counted those doing math and physics. You've removed them when you counted math and bio, and you removed them when you did physics and bio. So you've counted them 0 times. So you have to add those back in. And that's the correct formula. Okay? So now look at that table. It gives you basically all the information here. So what we're, okay, so we get from the table, let's change colors. So from table and formula, what do we get? We get this. So the total number of students studying math or physics or bio, we've counted that. So 100 minus 30, that's 70. Right? So that's right there. Okay. How many study math? I'm told is 32. How many study physics? I'm told it's 20. How many study bio? It's 45. Then I remove those doing math and physics. That's 7. Math and bio, that's 15. Physics and bio, that's 10. And then I'm going to add that last one, which I don't know what it is, but that's the one I'm looking for. But I have only one unknown, is that number, so it's easy to find, right? So solve for the single unknown. So let's see, so I'm going to get 70 minus 32 minus 20 minus 45 plus 7 plus 15 plus 10 is equal to that number I'm looking for. And so you take your calculator because you're lazy and you have better things to do. 70 minus 32 minus 20 minus 45 plus 7, and I messed up. I have to do it again. 70 minus 32 minus 20 minus 45 plus 7 plus 15 plus 10. I get minus 22. Isn't this great? Huh? Wonderful. I'm having a great day. Let's use a real pencil. 70. This will have to be negative. What the hell am I doing? Anybody sees the problem? I messed up somewhere for sure.
I think he gives 5.
Yeah, I have 5 when I do it.
Yeah, I have 5.
Okay, so I messed up in my calculation. That's good. Okay. You get 5. So how do you, 70 minus, how can you get 5? That's 97, right? So that's minus 27 plus 7 is minus 20 plus 15. Yes, it's 5. Yes. Whew. Okay, I was really, okay, this is good. Thanks. Okay, I just messed up on the calculator. So you get 5 is this. The universe was crashing before my eyes if this was a negative number. Okay, so we get 5. Yes, thank you. All right, so what does that mean? Let's go here. I hope did I, yeah, I love that. That's always great. Okay, so here's the picture. I've got 5 students here. Okay, so let's say I'm asked other questions about this whole thing. So now what I can do is this, okay? So this is math, physics, and bio, okay? I know that in math and biology, there are a total of 15 students. And I know that 5 take all 3. So how many does that leave doing math and bio only? That's 10, right? So let's just outline that one. Just to illustrate this. Okay, so once I know I have 5 basic algebra, switch signs. Thank you. You better send me a PDF, man. Yes. Okay. Where was I? Where was I? I'm totally lost. Yes.
Math and physics.
Yes, thanks. Yeah. Okay, math and physics, I've got total of 7. I've got 5 in there, so that'll give me 2 over here, right? And then biology and physics is 10. So that'll give me 5 over here, right? And then math, I've got 32 that study math, and I've got 17 over here, so that leaves 15 here, right, that study only math. All right, let's maybe outline that one in a different color. Right, like that. And for physics, I've got 12 already placed there, but a total of 20, so that gives me 8 over here. And then 20 already in biology, total of 45, so that's 25 that study only biology. And I had originally 30 students not studying any of these 3. Now, if you now look at the whole picture, everything should work as in the table, right? So that's it. Hopefully that this made sense. Yeah. No. Death.
Yes.
Yes. I got a yes. Yeah. Okay. So that's the examples for today. It's not like there are like zillions of different problems that I can do here. And as usual, the best is for you to do problems, and if you have questions, just let me know. Can you please re-explain? You can ask Brandon to explain it.
Yeah, it's the same thing. It literally the only reason why they were switched is because he did the algebra and didn't take the time and was lazy probably to move them over and switch them to negatives. So
Are you
he
talking
only
about
switched.
me? Is
Yeah.
he me? No, no,
No, maybe.
no.
I don't know. I usually okay. Well, okay. It is small, like it is a small screen, but like on paper, I always move it to the other side.
Yeah, I'll get back to the last part. But if you look at what I wrote, it's all correct. It's
Yeah,
just
it is correct.
when I input in my calculator, I did something wrong.
Is it
But
like
if-
different than in French and English, like the sides?
No.
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 Technically, you could do whichever side you want. It's just
Yeah, exactly. All right.
it's just the formula is based on something equals, and then the rest of the formula you could switch it around. It's the same thing.
Yeah. Okay. So again, let's go back here. Okay. So now we know that 5 students study math and bio and physics. Okay. So we've got, let's say this.
So the only thing that always messed me up with these charts, even back in like Sec 4, was sometimes they would give you a numbers to add, and sometimes they're just numbers like this. Like sometimes it's just like 1 1 1 1 like a charts, and not just the number itself to add. Like instead of having just the number 8, you would have like 8 ones to add up.
Yeah, but it's not. It's
Maybe. I don't know. I'm not sure what you're talking
like you
about.
won't have a problem with
Yeah.
8
I don't know.
ones
It's because back in the
physics
web works,
and
I was adding them up by accident. I don't know. There was something I did wrong.
Okay. Sometimes the questions are, I know that there was one, I don't know if it was in the WebWorks or where else, but where there was a certain ambiguity in the way that the things were phrased. So for example, in this table here, it says that 15 students study math and bio. If you interpret it as meaning 15 students take exactly math and bio, but not physics, then it's wrong, right? So it has to be clear that the 15 here means that there are 15 students that study math and bio, but some of them could be taking physics and some of them not, right? So that's the thing. Okay, so let me just finish this argument, which is related to exactly what we're saying. So this is math, physics, and bio, okay? So I look at this region here. This is the region math and bio. Okay. So what I know is, what I'm told is that there are 15 students who study math and biology. Okay. And I know that there are 5 that study all 3. So I'd like to know how many study math and bio, but not physics. So that's the remaining part here. So if I have total 15, that gives me 10 here. Yes. Does that answer your question, Hisham?